How do we solve for x? Solution: 8 to the power of x plus 4 to the power of x is equal to 36. 8 could be written as 2 to the power of 3 times x plus 4 could be written as 2 to the power of 2 times x equal to 36. This means that we can switch this power, so we have 2 to the power of x times 3 plus 2 to the power of x times 2 equal to 36. Now, let's suppose 2 raised to x is equal to m. This means that anywhere we see 2 to the power of x, we just write m. So I have m to the power of 3 plus m square equal to 36. Let's continue. This means that m to the power of 3 plus m square. So I move this 36 to the left side. I have minus 36 equal to 0. This means that m to the power of 3 plus m square minus 36 could be written as 27 plus 9 equal to 0. So m to the power of 3 plus m square minus 27 could be written as 3 to the power of 3 plus 9 could be written as 3 square equal to 0. Let's proceed further. M to the power of 3 plus m square minus times 3 cube, that is minus 3 cube, minus times plus, that is minus 3 square equal to 0. I can rearrange this equation as m to the power of 3 minus 3 to the power of 3 plus m square minus 3 square equal to 0. So I can also put these guys in brackets. So I have m to the power of 3 minus 3 to the power of 3 plus m square minus 3 square equal to 0. Now, recall that a to the power of 3 minus b to the power of 3 is equal to a minus b times a square plus ab plus b square. Also, recall that a square minus b square is equal to a minus b times a plus b. Take note of these two properties. This means that if I apply this property to this guy, you will see that this a is m and b is just 3. So I have m minus 3 times m square plus 3m plus 3 square plus. Now, if I apply this property to this guy, I simply have m minus 3 times m plus 3 equal to 0. Let's proceed further. You will notice that m minus 3 is common. I can pull it out. So I have m minus 3 into m square plus 3m plus, what is 3 square? That is simply 9 plus m plus 3 equal to 0. This means that m minus 3 times m square plus 3m plus 9 plus m plus 3 is equal to 0. This means that m minus 3 times m square 3m plus m, that is 4m, 9 plus 3, that is plus 12 equal to 0. So we have m minus 3 equal to 0, or m square plus 4m plus 12 equal to 0. From this line, m is equal to 3. Take note of this value of m. This quadratic equation has no real roots. Let's confirm that using discriminant formula. D equal to b square minus 4 times a times c. D equal to, from this equation, a is equal to 1, b equal to 4, c equal to 12. So plugging these values here, we have 4 square minus 4 into 1 into 12. D equal to 4 square, that is 4 times 4, 16 minus 4 times 1 times 12, that is 48. D equal to 16 minus 48, that is minus 32. Since the value of discriminant is less than 0, that means no real roots. There is no real root for this quadratic equation. We can ignore it. So we just have to focus our attention on m equals to 3, since 2 raised to x is equal to m. Let me show you where I got this from. It's from this line. Let's proceed further. This means that 2 to the power of x is equal to, what is m? M is 3. This means that I can take natural log of both sides. So I have log 2 to the power of x equal to log 3. Log 2 to the power of x could be written as x times log 2 equal to log 3. Let divide both sides by log 2. So I have log 2, log 2. Log 2 cancel log 2. We are left with x equal to log 3 divided by log 2. At this stage, let us recall a very beautiful property. It says log a over log b is equal to log a base b. This means that x equal to, applying this particular property to this guy, I have log 3 base 2. This is the required solution.